everyone, welcome back to the channel. Today we're diving into something that every NLP practitioner and language nerd should know: the different levels of language analysis in NLP. Think of this as your mental map for how machines understand human language, from sounds to meaning and beyond. In the next 15 minutes, I'll walk you through each level with simple definitions, crisp examples, visualization tips, and how each level shows up in real NLP systems. Whether you're building a chatbot, improving ASR, or training a semantic parser, this framework will make your decisions clearer. Let's jump in. Conversational, persuasive, informative. Before we break down each level, let's answer the big question: why does distinguishing these levels matter? Because language systems are built layer by layer. Errors at lower levels cascade up. Poor phonology makes ASR mess up words. Wrong morphology affects tokenization. Sloppy syntax hurts parsing. Shallow semantics limit understanding. And ignoring pragmatics breaks real-world dialogue. By thinking in levels, you design pipelines and models intentionally. Choose when to apply rule-based processing, when to lean on machine learning, and when you need context and world knowledge. That's the advantage of a layered mental model. Enthusiastic, explanatory. Here's the quick tour. Start at phonology, the study of speech sounds or their textual correlates. Next is morphology, how words are formed from smaller units. Syntax is word order and structure, sentence shape. Semantics is meaning. Pragmatics is context and speaker intent. Finally, discourse analysis looks at how sentences connect across an entire conversation or document. Each level builds on the previous ones, but often overlaps. I'll explain each with examples and practical NLP implications. Informative, friendly. Let's start with phonology. In spoken language, phonology deals with sounds, phones, and phonemes, and how they pattern. In NLP, phonology matters for automatic speech recognition, ASR, text-to-speech, TTS, and speech-to-speech translation. Practical issues include pronunciation variants, homophones, flower versus flower, and prosody, intonation that signals questions or emphasis. For text-only NLP, phonology influences grapheme to phoneme conversion and phonetic spelling normalization. If you work with low-resource languages or noisy audio, phonology-level modeling can dramatically improve results. Next up, morphology. That's the study of morphemes, the smallest meaning-bearing units in a language. Think stems, prefixes, suffixes, and inflection. Morphology is crucial when dealing with languages with rich inflection like Finnish or Turkish, or when building tokenizers and subword models. In NLP, we handle morphology with morphological analyzers, stemming, lemmatization, or subword tokenizers like BPE and WordPiece. Good morphological handling reduces vocabulary size, improves generalization, and helps models understand variants like run, runs, running. Analytical, lively now, syntax, the rules that govern sentence structure and word order. Syntax answers questions like, which words depend on which others? Dependency and constituency parsers live here. Syntax helps with tasks such as machine translation, information extraction, and question answering by revealing grammatical roles, subject, object, modifiers. Example, the dog chased the cat versus the cat chased the dog. Same words, different syntax, different meaning. In modern NLP, neural parsers and transformer encoders capture syntactic patterns implicitly, but explicit syntax still helps in low data regimes and explainable systems. Warm explanatory semantics is about meaning. Frame semantics, word sense disambiguation, compositional meaning, and semantic roles. This is where vector embeddings, knowledge graphs, and semantic parsers operate. Semantics answers, what does this sentence actually mean? Two challenges: lexical ambiguity, bank equals riverbank versus financial bank, and compositionality, how word meanings combine. In practice, semantics powers tasks like entailment, paraphrase detection, and context-aware search. Modern large language models capture a lot of semantics implicitly, but structured semantic resources and fine-tuned models are still essential for precision. Conversational, engaging pragmatics moves beyond literal meaning to intent, implicature, and context. Why did the speaker say that? For instance, can you pass the salt? Is literally a question about ability, but pragmatically a request. Pragmatics is vital for building realistic conversational agents, handling politeness, sarcasm, and indirect speech acts. It relies on world knowledge, speaker goals, and dialogue context. Models that ignore pragmatics often give correct but unhelpful answers. Techniques include dialogue state tracking, intent classification, and reinforcement learning for policy. Informative, steady discourse analysis examines how multiple sentences connect across a conversation or document. Coherence, anaphora, pronouns, topic structure, and rhetorical relations. Tasks include core reference resolution, who does he refer to, discourse parsing, summarization, and document-level sentiment. Discourse-level reasoning helps systems maintain context across long interactions, essential for multi-turn chatbots and summarizers. This level often requires memory mechanisms and models that can read and reason across long spans of text. Enthusiastic, practical. So how do these layers map to real systems? Quick mapping. ASR TTS rely heavily on phonology and prosody. Tokenization and morphological analyzers handle morphology. Parsers and syntactic features help structured prediction. Embeddings, semantic parsers, and knowledge graphs cover semantics. Intent models and policy engines address pragmatics. Discourse modules and memory models handle long-term context. When you design an NLP pipeline, ask, which levels are most critical for my problem? That drives data collection, annotation strategy, and model architecture. Step by step, illustrative. Let's do a quick walkthrough using one sentence. I didn't say she stole the money. Depending on prosody, emphasis, and context, this can mean many things. Phonology prosody changes emphasis. Morphology shows contractions. Syntax reveals who is the subject and object. Semantics helps interpret steal and money. Pragmatics determines whether the speaker is accusing or defending. Discourse tells us what happened earlier in the conversation. I'll show on-screen annotations as I read different variations and explain how each level flips the interpretation. Helpful, resourceful. If you want to explore these levels hands-on, here are tools and resources. Pratt and Caldy for phonology ASR experiments. Spacey, Stanza, and UD Pipe for tokenization, morphological analysis, and dependency parsing. NLTK and Allen LMP for learning and prototyping. WordNet and ConceptNet for semantic resources. Hugging Face Transformers for pre-trained models that span syntax and semantics. And co-reference libraries like Neural CoreF or Hugging Face pipelines for discourse tasks. I'll include links in the description and a study path for beginners. Concise, motivating. Quick recap. Language analysis can be usefully divided into phonology, morphology, syntax, semantics, pragmatics, and discourse. Each level targets specific linguistic phenomena and maps to different NLP tasks. Use this layered model to design better data pipelines, pick the right tools, and troubleshoot errors by isolating which layer is failing. Remember, modern models blur the boundaries, but explicit thinking about levels improves clarity and robustness. Enthusiastic, community-focused. If you found this helpful, hit like, subscribe, and ring the bell so you don't miss the deeper dives I have planned. Upcoming videos will include a hands-on ASR demo, a morphological analysis tutorial, and building a pragmatic dialogue agent. Drop a comment. Which level do you struggle with most in your projects? I'll pick the top comments for follow-up videos. Links to resources, code, and the timeline are in the description. Thanks for watching. See you in the next video.